Chapter 17, Differential Equation. If y is equal to x squared plus c, dy by dx, the first derivative is equal to 2x. Now, dy by dx is called a differential equation. Y is equal to x squared plus c is the general solution of this differential equation. And c in the general solution is called an arbitrary constant. And so a differential equation is an equation that has a derivative in it. And the solution of a differential equation is an equation that has no derivatives in it. All right, now the value of c corresponds to the boundary conditions in our problem. All right, and this is something that as we progress, we'll understand more of it. Now, as the boundary condition changes, the equation of the curve changes. All right, so as I said, as we progress, we'll understand more. The understanding of that last statement, or those two last statements, will become clearer. Now, one of the first things we need to know, we need to be able to classify differential equations. And this says, the order of a differential equation is the order of its highest derivative. All right. Now, dy by dx is equal to x is a first order differential equation. All right. Because you have a first order derivative. Now, d2y by dx squared plus 4dy by dx plus 3y is equal to x plus 2 is a second order differential equation. Because the highest derivative is second order. This is a second order differential equation. All right, linear versus non-linear differential equation. Now, a differential equation is linear if it exclusively involves terms with a power of 1. Now, d2y by dx squared plus dy by dx plus 3y is equal to x is a second order linear differential equation. Now, even though the differential equation is second order, it's a linear differential equation because it exclusively involves terms. All the terms in this differential equation exclusively have a power of 1. Now, first order differential equation. Now, dy by dx is equal to f of x, a function of x, is an example of a first order differential equation. To solve this differential equation, we integrate both sides of the equation. So to solve a first order differential equation, we integrate both sides of the differential equation. Now, when the value of the arbitrary constant c is known, the solution of the differential equation is called a particular solution. So earlier we said, when you just solve a differential equation, what you have is a general solution. Now, when through the boundary conditions, you determine the value of c, the solution you now have, once this value of c is known, is called a particular solution. All right, so let's see if we can have a look at one or two examples. Example 1 says, solve the differential equation dy by dx is equal to 2x plus 3. So let's write it. dy by dx is equal to 2x plus 3. So what I'm going to do now, I'm going to bring my dx over here. So now I have dy is equal to 2x plus 3 in bracket dx. Then I'm going to integrate both sides. The left-hand side, I'm integrating with respect to y, and the right-hand side, I'm integrating with respect to x. Now, dy is the same as saying 1 dy. If I integrate 1 with respect to y, I'm going to get y. So y is equal to 2x squared over 2 plus 3x plus c, which is the constant of integration. And so y is equal to x squared plus 3x plus c. Now, this solution is called a general solution, and essentially that is because I do not know the value of c. Example 2. In example 2, we're asked to find the general solution of the equation 2 over x plus 1 dy by dx is equal to the root of x. All right, what I'm going to do is I'm going to take everything over here and bring it over here. So now I have 2 dy is equal to the root of x into x plus 1 dx. Then I'm going to integrate both sides. All right. So if I integrate 2 with respect to y, I'm going to get 2y. And over here, it's equal to the integral of x to the 3 over 2 plus x to the half power. And I'm integrating with respect to x. All right, so what happened there? What I did is I removed the brackets by applying distributive law. The root of x is the same as saying x to the half power. If I multiply x to the half power by x, I'm going to get x to the power, which is 1.5. 1.5 is the same as saying 3 over 2. If I multiply the root of x by 1, I'm going to get the root of x. And the root of x is the same as saying x raised to the half power, 1/2 power. So let's integrate the right-hand side. So now I'm going to get x to the 5 over 2. So I increase the power by 1. Then I divide by the new power, which is 5 over 2, plus x to the 3 over 2. I increase the power by 1. And then I divide by the new power, which is 3 over 2, plus c. Now, dividing by 5 over 2 is the same as saying multiply by 2 over 5, sorry. So this is 2 over 5, x to the 5 over 2, plus 2 over 3, x to the 3 over 2, plus c. So this is what 2y is equal to. All right, so I would have arrived at the solution of my equation once I know what y is. So if I divide both sides by 2, I'm going to get y is equal to 1/5 x to the 5 over 2. What happened to the 2? The 2 cancel the 2 because I divided by 2. Plus 1/3 x to the 3 over 2. Again, the 2's cancel. Plus c over 2. Now, instead of saying c over 2, I'm just going to replace c over 2, which is a constant, with a new constant, and I'm going to call that constant d. So y is equal to 1/5 x to the 5 over 2 plus 1/3 x to the 3 over 2 plus d is my general solution. Example 3, it says, find the particular solution of the differential equation x squared is equal to x squared dy by dx is equal to 4 minus x to the 4th power when x is equal to 1 and y is equal to 2. Now, x is equal to 1 and y is equal to 2 is what we call your boundary conditions. And when the boundary conditions are applied, that will assist you to determine the value of c. Once you know the value of c, your solution will now be called a particular solution. So let's get to it. I have x squared dy by dx is equal to 4 minus x to the 4th power. I'm going to divide the entire equation by x squared. So now I have dy by dx, these two cancel, is equal to 4 over x squared minus x squared. Next, I'm going to say dy is equal to 4, and then I have x to the minus 2 minus x squared dx. After this, now I'm going to integrate both sides. So when I integrate dy, I'm going to get y is equal to 4 x to the minus 1, increase the power by 1, then divide by the new power, minus 1, minus x to the third power, divide by the new power 3, plus c, constant of integration. So now y is equal to minus 4 over x minus x to the third over 3 plus c. We must remember the boundary conditions, which are x is 1, when x is 1, y is 2. So when x is equal to 1, y is 2. I'm going to apply the boundary conditions now in order to determine the value of c. I'm going to get 2 is equal to minus 4 over 1 minus 1 cube over 3 plus c. This is 2 is equal to minus 4 and 1/3 plus c. Now, c is going to be equal to 2 plus 4 and 1/3, which is 6 and 1/3. Or if I want, I can say this is 19 over 3. And so by putting in the value of c in my general solution, I'm going to get my particular solution. And so y is equal to minus 4 over x minus x to the third power over 3 plus c, which is 19 over 3, is my particular solution.